Welcome back. In this episode, we build a cable assembly machine, upgrade our cobblestone generator, and overclock our ore processor. Spoiler alert, it's 4 times faster! This is Star Technology. Let's get into it. So here's a quick recap of how we make tin cables. Take this bucket, pull some liquid latex out of the fluid cell, come over here to the crafting table, extract the rubber from the bucket, head over here towards our mixer setup. We throw the rubber in, we throw the sulfur in, put some charcoal in the burner, and then light it. We collect the cured rubber and place it on the mechanical press, grab some tin wire and the rubber sheets, and that makes tin cable. That works for us, but it's very manual and labor intensive. We could create an automatic crafting system for this using automatic crafters where we reuse the bucket and it just extracts that raw rubber. I think we're at a stage in our advancement where that is just too primitive and we should be moving forward and looking for other ways of doing this, like more high-tech ways. So this is the standard recipe for tin cables, some tin wire, those rubber sheets, and that makes tin cable. When we advance to the next tier, which is MV, we're going to need to do the same thing with copper. However, copper cables do not have that kind of a recipe. We have to use an assembler. So for tin cables, the same situation applies. There is actually a recipe for tin cables that uses liquid rubber in the assembler. So this project is actually going to be quite interesting because it's the first time that we're going to be creating a specific process that involves multiple machines of different types all kind of chained together and various different industrial processes. It'll give us a good introduction to the sort of the GregTech way, because we'll be doing a lot of things where we take one product, turn it into another, turn it into another, turn it into another to finally get our actual product at the end. Down here is our shiitake spore production. I've got a pipe that's coming out here, which I'm going to connect up to there to the electric furnaces. The shiitake spores will come into this furnace, they'll be cooked, they'll automatically output into this electric furnace as slime balls. The slime balls will be cooked and they'll output into this, which represents a chest. So then after that, I'm going to have a centrifuge, which will take the sticky resin and turn it into various products, one of which is glue, one of which is raw rubber pulp. After that, we'll use a chemical reactor on the raw rubber pulp with the sulfur, which will create the rubber that we need, but as a liquid. And then that will feed into this block here, which will be the assembler, creating cables. So we still have our old assembler over here. So these are all our sort of general purpose machines that we'll use for various projects. But what we're going to start to do is build special sequences of machines that are for a very specific purpose. So this entire run here will just be for creating cables. Or more specifically, to create the rubber to allow us to create cables. We will do this step by step. I've laid it out like this just to make it easier for me to get my head around it, because it is kind of complicated with how everything has to be wired up. And it took me a little while to kind of visualize it. So rather than sort of do it on the fly, I thought it'd make more sense to kind of do this kind of thing and just make sure I had enough space to do it. Because, as you can see, there's quite a lot of pieces in this puzzle. But so let's get cracking on it. So this is what the electric furnace looks like. It's pretty simple. Got some electronic circuits, machine hull, some copper wire, some tin cables. So let's create 2 of those. Let's get them installed. Okay, so next we want to get the input over here. Bring that over. So that's already filling up with shiitake spores. So the next thing we want to do is hook this up with power. What I'll do is I'll run a power cable all along here. And we'll use it for all the machines as required. So as you can see, it's already started cooking. It's taking only 4 EUs per tick. It takes about 10 seconds to process. So it's not very quick, but the way that we're going to be using the liquid rubber, I think that'll be okay. As you can see, currently it's just building up in here. What we want to do is actually have it output into this machine automatically. So we can do that via the configuration menu here. So in this view here, you can see the surrounding blocks around the furnace. And if you select a side, you can change how that side is configured. So in this case here, we want this to be automatically output. The way of doing that is just to click it a few times. It's set as an output, and now it's set as an auto output. So that should start feeding into here, which it is. We need to make this connection here. And now that is cooking into sticky resin. put an oak drawer in. So same situation here. If we tell this to auto output, it'll start outputting into the oak drawer. So that's the first section done. So next up, we need a centrifuge. So this is the recipe that the centrifuge uses to turn the sticky resin into raw rubber pulp. This may be new to some of you. There's multiple outputs for this particular processing task, one of which is a liquid, one of which is a solid that we don't need. So we need to be able to handle these two outputs as well as this liquid coming out. So they're pretty simple, just electric motors, electronic circuits, and tin cables. Centrifuge is in. Let's hook it up to power. So now that centrifuge is working, so we should see those products there. We might not get a plant ball the first time, but we will have to deal with it. So while that's working, we want to create a couple of drawers here to contain the products. Okay, so now that that's done, we'll hook these up with a small brass item pipe. So we need to configure this to be automatically outputting. So select here and auto. So now those will be filling up, which is perfect. But we still need to deal with the glue. So that glue, being a liquid, will not go through these item pipes. What we'll do is we'll build a tank to collect that, because the glue is a really useful byproduct. Probably need a bigger fluid cell than this long term, but this will contain 32 buckets, and we're outputting, I think, 100 millibuckets per cycle. Now we're going to need some pipes to pull out the contents. So let's use a small bronze fluid pipe. Configure that. Now we need to set that to be auto output. And I think we also need to set that to be able to accept on that block. I can't remember if you need to do that bit. So this is now the top. We don't want to click here again. The default is to change the output for items. So we need to click this button here instead. That is now auto outputting through there. So as you can see, the pipe itself has glue in it as it transfers over. And as I suspected, it's not quite going into here yet. So I believe I do need to configure that top thing as a input. Right, so the way we do that is through this configuration here. So the top one, I think, is this one. But that should now be filling up. So as you can see, yeah, the sticky resin's coming in quicker than it could process it, but that's fine. So we've got some raw rubber pulp appearing and these plant balls, which are a byproduct as well. We'll deal with them later, but for the moment, we'll just let this fill up. We've got a lot of capacity in this chest, so that's not a problem. So next up, the chemical reactor. So this is the recipe that we'll use in the chemical reactor. So 9 raw rubber pulp and 1 piece of sulfur turns into slightly over a bucket of liquid rubber. So the basic chemical reactor is just some glass, a tin rotor, electric motors, machine hulls, and yeah, so all the kind of components we already know about. Let's put this in place. Now that's coming in. Now we need another input, which is the sulfur. For the moment, I might just hook up a hopper. Place that there, drop in the sulfur. And that has created a problem because that's already filled up. That's interesting. Oh, I guess I'll just do that for now. Wonder how we stop that from happening. Okay, in either case, that has now started to work. So this should be outputting liquid rubber. So now there's a bucket of liquid rubber. So what we need to do now is build an assembler and just have it pull inside. So the basic assembler, just the robot arms, conveyor modules, etc. We built this last episode, so it's nothing new to us. Then configure this to auto output. We want to auto output the liquid. And that's now got liquid rubber in it. We'll configure this to auto output. Now we'll just place this in here. And that is making our tin cable. Got some glue, already got 3 buckets worth. So that's going to fill up pretty quickly. We'll have to deal with that soon. So one thing I forgot to mention is I need to lock both of these drawers so they don't get mixed up, because if plant balls were to go into here, it would stop this from working. So I want this to always be the raw rubber pulp. So that's now done. What I thought was going to be a problem has actually become a problem, which is that once the sulfur ran out in the hopper, the raw rubber pulp has filled both the inputs from the chest. Well, that's not going to work for us. We're going to have to fix that. I've figured out how to do that, but we're going to have to replace this pipe and build a few additional components. So let's do that. So really what we want to do is make sure that the amount of raw rubber pulp that goes into that machine is never more than 64. We can probably achieve that with a robot arm. We'll have to use a different pipe. We'll have to use the GregTech pipe rather than the pipes one. But if we put the robot arm onto the machine on the input side and then apply a filter to it, we should be able to say don't have more than 64 items. And that should stop it from putting it into the other slot. So we're going to need an item filter, which is this one here. So that's made from zinc foil and steel plates. And we can just craft that. So we need to make some zinc foil. Zinc foil we can make like that, or we can put it in the bender. Program circuit 10. This is what the pusher upgrade looks like. This upgrades oak drawers to push out into a pipe. So tin plates, redstone, and the conveyor module, which we've got. Disconnect this pipe. So place that down there. Now we can hook up this side here. And then what we want to do is on this block here is add the rubber arm. So if we do that, it's put it on the front face, which is not right, but we can actually edit it in the object itself. We come into here and go into this cog thing. You select a particular side, it has this little slot down here, and that's where the upgrades go. So this button here allows you to configure it, but it's in the wrong slot, so we'll take that out and move it to the right one. So now it's on the left face. This is the user interface for the rubber arm, so it specifies how many to move at a time, if it's going in and out, and what sort of mode it uses. This is the spot for the item filter, so we'll place that in there, which gives us access to this. What we want to do is say we only want a certain amount of stuff, or actually I think it'd be better to say we want to keep a certain amount in this machine. So instead of supply exact, we'll go to keep exact. We want the mode to be not export, we want it to be import, because we're going from the pipe into the machine. So that's an import action. And this is the filter, so we want to say 64 of the raw rubber pulp is the maximum that we want to have come into here. This is empty, that is there, so now all I need to do is hook this up. And now we need to put the pusher upgrade in here. So we're going to be pushing from this oak drawer in this direction, which is south. So we need to upgrade this. So just right clicking on the item changes the thing. There we go, direction south. So pusher upgrade. And now you can see it's feeding through, but it should stop at 64, which it has. So that keeps this slot free. Now, in theory, I think I should have to do the same thing on this upper face, because if there's more than 64 of the sulfur, it'll do the same problem, but in reverse. So not sure I can use a hopper with that. I think I'd have to use a pipe. But for the moment, the hopper is the one that's going to be not filled very often, so I think that will work. So one of the possible upgrades you can do for the oak drawers that are part of the functional storage mod is this thing here, which is called a void upgrade. This is pretty useful because once the oak drawer fills up, any items that try to be added to it will be automatically destroyed. It sounds bad, but that's actually pretty useful because it means the oak drawer will always be a valid destination for that particular item. It won't try and put them elsewhere. So the void upgrade is pretty simple. It's just a soul infused plate and some obsidian, but we don't actually have an easy way to make obsidian. In order to do that, we're going to need a continuous source of lava. And one way to do that is with the large stone barrel. The large stone barrel is a multi-block. That's the controller. The base blocks are just stone bricks and the walls are just stone. So pretty simple, very similar to the wooden barrels that we built. Using this recipe here, if we feed cobblestone in and supply a soul campfire, which is not consumed, it produces a quarter of a bucket of lava. So now that we have a continuous source of lava, we need a way to turn that into obsidian. And one way to do that is with a stone barrel. So you're feeding it a continuous stream of lava with water on the top, it produces obsidian. So we'll use this for the obsidian production, and we'll use the large stone barrel for the lava production. So let's get to it. Okay, that's a valid structure. So we'll have the oak drawer at the bottom. So place that there. So now that block there can be the output hatch. And then fluid pipe from there into there. Okay, that's hooked up. So the lava should flow into there. And now if I place a source block there, now we need 2 input buses. So we'll place the soul campfire in there. Now we just need a source of cobblestone there. Alright, there we go. Should be filling up with cobblestone. It doesn't look too bad. It's not the worst thing I've ever seen. There we go. So this isn't exactly quick. It's going to be basically 40 seconds to produce 1 obsidian. We're not going to need too much of it, so I'll just let this run away and produce as much obsidian as it needs to. So that'll just keep filling up eventually. So this is the cobblestone generator that we built way back in episode 2. It produces cobblestone, it feeds through into here. I have a pipe that feeds it into the millstones, which grind the cobblestone into gravel. I then take that gravel and carry it over there to be processed in the sieves. And then I also take some of it and put it into the low pressure steam forge hammers over here, turning it into sand, and then I grab that sand and turn it into dust, like run it through again. We don't want to be doing that. We're in the electrical age now. We don't want to be messing around with steam. Let's create a new process that creates cobblestone, gravel, sand, and dust for us automatically. And we will do that over here. So here's another project that we've got going. So what we're going to use is igneous extruders. So there'll be a set of 3 igneous extruders here, which will each be outputting cobblestone. Those will be feeding into this set of 3 machines. So these will all be forge hammers. So this first one here will smash cobblestone into gravel, and then we'll pull a feed out of that. This one here will do the same thing with gravel, but then also process it from gravel into sand. And then this third one will do 3 steps. So gravel, sand, dust. And that will be our production of those resources. We'll feed that into containers down here, which I've already got set up, because that's just up above. And then basically, for the moment, I'll carry it just from there to there, which is pretty quick, but I can then run pipes directly into these inputs once we have made our ore processing more efficient, which we'll do later in this episode. Igneous extruder is a pretty cool block because it's capable of producing different stones passively without requiring any power. The only requirement is that certain blocks need to be around it. So we need a block of lava and a block of water. So one of the ingredients that the igneous extruder needs is a bronze gear. The way we used to make these is pretty straightforward. So just some bronze rods, bronze plates, and a wrench. We could do that right now. The alloy smelter allows us to use a casting mold to simplify the process. So instead of having to create lots of plates and rods, we can instead use 8 bronze ingots and a casting mold. So let's do that. So to create a casting mold, you start with an empty mold, which is just constructed like this. So a series of 4 steel plates and a few tools. And then we shape that to create the mold that we need. So depending on the orientation of the hammer and the mold, you get different results. So for example, this is the recipe for making a casting mold that creates gears. This is one for ingots. This is one for bottles. This is for blocks, etc. What we're going to need is the casting mold for gears. Here in the alloy smelter, we just place the casting mold for the gears and the ingots, and it starts to create them. Okay, so we have the bronze gears, and so I think we're ready to make the igneous extruders. There we go, 3 of those. This is where the igneous extruders are going to go. We want to be able to have some chutes underneath them, so we'll create them up on top of here. Next up, put those in, configure them to extract. Next, we'll add water source blocks and lava source blocks on each side. As you can see, this is now producing cobblestone. This one here isn't yet because this isn't a source block, that's just flowing lava, so we need to fill that in. Okay, so now they're all producing cobblestone. So the rate is about 1 cobblestone per second. And now we just need to build the forge hammers. Do you ever have that feeling that you're being watched? Now we need to create some forge hammers. We're gonna need 6 of them. Looks like it's just tin cables, some electronic circuits, pistons, and some anvils. Oh. So, we've run out of electronic circuits. It finally happened. So I just remembered that in the shop, there's actually the option to buy 16 LV circuits for the cost of 16 star T coins. Now, I have quite a few coins, and I think just to get us over the line with this particular craft, let's just do that, and then we'll worry about building a basic electronic circuit process later. And then the last forge hammer. Great. Okay, so we got 6 basic forge hammers. Whew, okay, that was a bit scary there for a moment because of these electronic circuits. I think one of the big things we're going to have to do sometime in the future is build this basic circuit assembler. Most of it is easy to build. A couple of parts of it are very challenging, but I think that's something to aspire to. I think we'll work towards that. Not in this episode, but in an upcoming episode. So let's go get these installed. I did leave those holes there because that's where I was going to run the wires. We want that to be the output there. Given that we're going to feed it into those drawers that are just below here, we can actually join these together. They don't have to be separated. That seems alright. So they're going through down into there. Alright, now all that remains is to hook up the power to these things. That could be the place where the wire goes down. And then electrical connector, overcharged wire. That should have power, it does. And now I just got to hook up the rest underneath. There we go. So we should start seeing these going up quite quickly, actually. Look at that. The dust. Okay. Okay, so they're doing the job now. So this is creating the gravel. That's turning the gravel into sand. Gravel, sand, dust. One thing we do need to deal with is this noise. So luckily in GregTech, there's the option to use a hammer to silence things. So you can see it's got like a little sound thing. So click that on the noise-making blocks, and now it's nice and quiet. So now we have automated our gravel, our sand, and dust production. So we no longer have to do any juggling of these resources to create the others. In the time between videos, I created this here, which is another sifting setup for sand. So this is using the flint mesh, as you can see. Output of that is a few gem ores. Underneath the floor, I've got all of the item pipes hooked up so that we've got like sort of a bank of all the ores that come out of sifting gravel and all the ores and things that come out of sifting sand. So yes, I do have a staircase that goes to nowhere currently. That's because this will eventually go to the next level up. And one of the ways I like to sort of build my factories and just builds in general is I don't necessarily have a good idea as to what I want the finished thing to look like, but I might have an idea about certain aspects. So this room, for example, I wanted it to be tall, in contrast to this one here, which was a bit more tighter in terms of like ceiling height. So I thought, okay, I want this to look kind of grand and tall ceilings. So I built these kind of structures, and then I realized, oh, actually that'd be pretty good for running the power cables. So they were used to run a bit closer to the ground, and now they're way up there out of reach. But yeah, it's still a design that I'm evolving. We need to address this. So this is far too slow. So it's taking 8 seconds per wash on that thing, and there's some of the more advanced ones, like the chalcopyrite takes 16 seconds. So we can actually overclock these. So what that involves doing is essentially upgrading them to the next tier of electricity. They're currently running at LV, which means they use 32 volt packets. But by adding a second energy hatch, we can actually upgrade their internals to MV effectively. Because each LV input hatch, these ones here, can actually take 2 amps. So the way that the different energy tiers work is that LV is 32 volts, MV is 128 volts. And the way that EUs work and the way they're consumed is kind of like as if they're volt amps. You can work out the EU consumption by working out what the voltage is and how many amps it's consuming. In this case here, because it's 32 volts at 2 amps, which is the maximum an energy hatch can have, if we add a second energy hatch, now it can handle LV at 4 amps, which, if you do the maths, works out to be MV. And the side effect of that is the processing is 4 times faster. So we're not going to have enough energy to run both of these ore processors off this one LV4A energy converter, because this is only 4 amps. And as I said here, this is 2 amps, and the second one will be 2 amps as well. So we need 2 of these. So I'll create a second one over here, as the sign indicates, and hook that up separately. First things first, let's disconnect the power to this other one. If we change that to... So now, as you can see, it is actually MV, 112 EUs per tick, and it's not being supplied enough energy from that one connector. So if I connect the second one, now it should be running fine, because 32 volts times 2 amps is 64. 64 plus 64, 128 in total. And the actual recipe that it's currently processing only requires 112. So that's working. And as you can see, it is going a lot quicker. So 4 times the speed, 4 times the energy use, that is a fair trade-off, I feel. In fact, yeah, I think that's actually a very good trade-off, because often in these things, when you overclock it, you lose some energy due to inefficiency. But here we've got perfect efficiency, which is amazing. So we'll do the same for this guy. The soft mallet. Done. And run that over here. So this is running a different recipe than this one. So whatever it's processing is not as energy intensive, because this is only 96 EUs per tick. So I'm guessing it's probably the gold ore. Here we're running into some small problems with energy, maybe. Might have hit the limit on how much energy I can use at the moment, or supply. I'll have to do some maths. Actually, I might replace that cable up there. Maybe that's the problem. Because this is 8 amps coming through here. Oh, 8 amps should be fine on this cable. Yeah, you can see these energy hatches are only just keeping up. Oh, hang on a second. So the problem, as it turns out, is this distillery here. So the distillery is using 30 EUs per tick, and it's on the same circuit as this one here. So together with those 2 hatches, it sometimes goes over 128. So that can't supply enough. What I would have to do is I could create a 16 amp energy converter, which would then overload this wire, but we can build double soul infused wire. So the LV 16 amp energy converter requires 16 times. So much, much better. So let's build one of those, I guess. So 16 amp, 32 EU out. Use the 4 times wire. Really hope I've done this right. We'll find out in a moment if it explodes. And put that there. Okay, so that's all hooked up. Now I just need to replace this connector. And here's a moment of truth. Hopefully it doesn't explode. Still struggling. Why? Ah, because that's not plugged in. Alright, here we go. Problem solved. Okay, now I'm starting to second guess myself. Well, not second guess, but rethink this. Because now this is enough to run this and that. I will redesign this at some point, I'm sure. I'll come back to that. The really big piece of news is this is now running at full capacity, flat out, without any power issues. Brilliant. So our dust storage wall is looking pretty impressive now. There's a lot of different products that we have here, and the numbers are going up quite well because of our overclocked electrokinetic ore factories behind us. One thing I've had to do behind here to sort out some problems is actually rearrange how these are connected. So I've kind of created this snaking kind of pipe system here. Originally I had them connected sort of like in a lattice all the way across, but the problem there was that essentially it would fill them in based on proximity to this chest here. So it would do this one, then these two, then those three, then those four, then those four. I just didn't like how that looked, so I've created like a snaking kind of shape, and the same for this one here. One thing that I do want to do is talk about this sphalerite dust. Sphalerite dust is zinc sulfide from the looks of it. So as near as I can tell, sphalerite dust actually serves no purpose itself. It's used to get other things. So sphalerite dust, if you smelt it, it gives you zinc. So that's how we were getting zinc early in the game. If you put it in the electric blast furnace with some oxygen, you get some zincite and sulfur dioxide, but that's quite far off for us. That's MB. We're not even close to having that working yet. There's bulk blasting, which gives us the zinc again. It's not used in any processes, really. The only thing that it is actually any use to do with it is this electrolyzer. So 2 sphalerite dust turns into zinc dust, sulfur dust, and a 5% chance of getting some gallium. Now, zinc and sulfur are 2 things we already have some of. And this is LV tier. And the electrolyzer is one of the machines that we haven't built yet, but we actually need for progression. Why don't we do that and just set up the task of processing all of our sphalerite into zinc and sulfur? Because it seems like they're more useful to us. So what is involved with a basic electrolyzer? Pretty simple, some circuits, tin cable, gold wire, actually high voltage, but we can still make it because we can just put some into the wire mill. I was thinking of putting it here, as you can see. So done, zinc and sulfur. So we already have destinations for those, basically on this wall behind. All we need to do is somehow pipe the sphalerite into here. I'm actually thinking maybe we hook this up permanently. Maybe I'll put the sphalerite oak drawer here somewhere and actually have it hooked up, and then have it just export straight into this wall here. We'll output from the top, I guess, and just pipe that straight into that system. If I change that top one to be auto extract, that's the sphalerite drawer. If I put that there and hook that up, that'll start working. Go like this, I plug that in to there, and that will just process all of our sphalerite dust into zinc and sulfur. So we don't need that thing there anymore, so I guess we'll just remove one of the others. Cool. Alright, so sphalerite is no longer something that we need to store here. We'll probably do the same thing with this pyrite. Any of these numbers getting a bit big? That a lot of iron. Oh, that's good. Probably need to start thinking about making those void upgrades. Let's check on the obsidian production. That's less than I thought, but plenty for what we need. So quite comfortable to let that keep going. We probably should tick off some of these quests because we've just completed quite a few. So we've got the electrolyzer, we've got the chemical reactor, the centrifuge, the forge hammer. So what's left? We have the macerator we haven't created yet, so that would be useful. But the electric blast furnace has come within our reach now, and so is the arc furnace. So to run the blast furnace, we're going to need a source of oxygen. But what I'm thinking, we have a large supply of this guy here, which is magnetite, which is iron and oxygen. So if we electrolyze that, we'll get a load of oxygen and the iron that we need anyway. I'm wondering how viable that is as a oxygen source. And similarly for cassiterite is tin and oxygen. So it seems like electrolyzing might be the way to go to get oxygen. I know that on the quest tree, a gas collector is another way of getting it. So magnetite dust, when it's electrolyzed, so 7 of those produces 4 buckets of oxygen gas every 10 seconds. So what does the gas collector do? Yeah, so this every 10 seconds it grabs 10 buckets of air. There we go. So we centrifuge, and it creates nitrogen and oxygen. The 10 buckets of air produces 1 bucket of oxygen gas every 80 seconds. Wow, okay. Yes, that's not great at all. So I think it's going to be much more viable to produce our oxygen for the blast furnace using electrolysis instead. This time is terrible. I guess we'll see what the demands are in terms of the electric blast furnace. Well, I think that just about wraps it up for this episode. We've got quite a lot done. Got the new cobblestone generator behind me. I've done some aesthetic improvements to it just to make it look a little bit nicer. We also overclocked our ore processor, which is going much faster, so we have loads of resources, which has really set us up for our journey to MV, which is beginning pretty soon. Thanks for watching, and cheers!